Okay, this is a periodic table of the elements. Uh, the vertical one we call the group or family. Totally you have 18. Okay, now horizontal we call period. That's why we call periodic table. 1 and 2, the first period. 3 all the way to 10. There's 8 of them. Second period. Third one also has 8. Then you have more. 19 to 36, 37 to the 54. So totally we have 7 period. The elements in same group are very similar, not the same. They are very similar, very active, very similar. This one very inactive, right? Okay, now horizontally very different. You start with very active metal, then activity decrease, then change from metal to non-metal until very inactive non-metal. Start over another very active metal, then activity change and to a very inactive non-metal and start over again. Okay, so that's a periodic law. Okay, then the middle part we call transition elements, right? And also two rows separate. So if we want to find between 57 to 72 or between 89 to 104, right here. The first one we call real Earth. That's RARE, real Earth. Now second one we call actinides. The different color, the red one is the gases, all the black, solid, and you can have you can find two blue color, they're liquid, right? And some of man-made elements has no color. So the last one we can find on Earth is uranium. Then start 93 up to 103, then start 104 all the way up. Man-made elements. Scientists made them in the lab. So please remember. Okay, if you find elements has no color, that is man-made elements. Okay, so now let's go back to lecture. And on the left side of the table, the bottom, you can find the example. Help you understand the question like how many protons or electrons, atomic weight, unit is U. Okay, this number here is not required. The two, see, for zinc, the two tell you these elements always give 2 electrons. And also this one here, the AR, that's argon. Okay, then 3d10 for S2. This tell you how many electrons in every energy shell. It's not required. I will not ask you. So you should know how to find the name, the number of electrons, protons, atomic weight, and the boiling point, melting point, density, include unit. Okay, so we just discussed the group and period. The vertical column called group. Elements in same group are very similar. So total 18. Horizontal rows called periods. The elements in same periods are very different. Remember from the active metal to inactive non-metal. So totally I have 7 transition elements. Real Earth. The reason we call real Earth because very small amount in nature. And actinides from 90 to 103. They are radioactive, and most of them are made in lab. We call man-made elements. Okay, next page. This is the periodic table. I ask you make a copy. Okay, so we continue. So now we're going to discuss energy shell and subshell. Okay, in an atom, each electron has a set of quantum number. Remember how many? Every electron has 4 quantum number. You cannot find 2 electrons that have the same quantum number. Each has 4, at least one must be different. So now 2 electrons can have same set of quantum number. At least one number must be different. So now when electron fill in, remember this is the nuclear, which is very small compared to size of the atom. It should be like a piece of a blueberry inside of what football stadium. Okay, very small. So now the first energy shell. Okay, this energy shell scientists find can only hold up to 2 electrons. The maximum is 2. So when this one has 2 electrons, that's helium, has 2 electrons. So next atom, lithium, has 3. The third one had to go higher energy shell. Go to the second one. The second one can hold up to 8. So that's the neon has totally 10 electrons. The first one has 2, second one has 8. So closed. Then we start a third period. So that's a sodium, so on. Why we can have more electrons when the n number increase? Because scientists find there are subshells. When n equals 1, really just a single shell like this, just one shell. We just look at this small part. So if you carefully look at the second energy shell, well, the second energy shell has 2 subshells. They're very, very close to each other. Okay, so that's like you have more room. So you can hold more electrons. The second one can hold up to 8. Now, the third one, when n equals 3, the third shell has 3 subshells. And similar, the fourth shell can have 4 subshells. So that's 1, 2, 3, 4. More rooms, so more electron can fill in, right? Okay. So that's the definition of shell and subshell. The shell is the electron with same n. Okay, so now the electron have similar energy and about the same average distance from the center. The subshell's electron with same L, the second quantum number. Okay, they're going to have same subshell. This electron in same subshell have nearly same energy. But they should go different angle. For example, they're not going to stay right here. They stay one here, one there, try to be separate. Okay, because electrons always repel each other. So now, when electrons fill in, they follow 3 rules. So we call 3 rules. The first one, each electron must have a different quantum number. So each electron has 4 quantum number. 4 quantum number. Okay, at least one should be different from others. You cannot find 2 atom, 2 electrons that have the exact same number. Okay, just like you cannot find 2 students that have the same ID number. Impossible. So now Rule number 2, the atom is more stable when the total energy is minimum. So you can think this way. Electrons always go the lower energy state first. Fill first one first. When first one closed, go the second one. When second one closed, you go the third one. So on. Okay, now rule number 3. So please remember this one. The outer shell, that is last shell has electrons, cannot hold more than 8 electrons. So for the last energy shell, always say the highest energy shell, which has electrons. The maximum number is 8. The outer shell cannot hold more than 8 electrons. So please remember this. Every electron has 4 quantum number, and the last energy shell cannot hold more than 8. 8 is maximum. 4 and 8 is 2 important number. Okay. Shell or subshell become closed when it contains the maximum number of electrons. Okay, and closed one is the most stable one. Okay, so now I'm going to give you a demonstration, have you understand the energy shell. Okay, the hydrogen is the first element in periodic table, right? Only 1 proton and 1 electron. So now look at the energy shell. The first one has 2 rooms. Now the second one has 1, 2, 3, 4. Okay, come this side. 5, 6, 7, 8. So you can hold up to 8. Third one, if you count 18, 36. But can you have 36? Depends if you have another shell. If number 4 is last one has electrons, by the way, you can only hold how many? Up to 8. Okay, and also the third one. Can third one hold up to 18? Depends if the third one is last shell or not. If it's not, you can hold up to 18. If it's no electron in number 4, number 3 can only hold up to 8, not more than 8. Okay, so let's continue. The first one, the hydrogen, has only 1 electron. Okay, we have more room. So now the second one, helium. Helium has 2 electrons. So first one, second one. Let's say this term is big enough for both of us. But now it's closed. No more room. Okay, so now if you look at the periodic table, the first one closed. First one closed. So then we start the second period. Lithium, 3 electrons. So here's 2. In first energy shell has 2. Okay, and lithium has 3 electrons, and third one still right here. Second energy shell. So now we can discuss only second energy shell because first one closed. We change color to yellow. Okay, next one, beryllium. Okay, 2 electrons in second shell. Okay, so then boron, 3 in second energy shell. Carbon, 4. Carbon has 6 electrons. All right, 2 stay inside and 4 in second one. Okay, then nitrogen, 5 in second one. Oxygen, 6. Fluorine, 7. Neon, 8. Say 1, 2, 3, 4, 5, 6, 7, 8. So now the second one closed. No more room. Okay, so now the next elements, going to go, the electron will go the third energy shell. So if you check the periodic table, let's start third period. Let's check this real quick. Right here. See, the first one, first period only has 2 because 2 is maximum for the first one. Now the second period can hold up to 10 electrons. The first shell has 2, then second one has 8, total is 10. So second one closed. So then nature open the third flow. We start third period. The sodium. Okay, so 11 electrons. 2 stay the first one, 8 stay second one, the 1 stay in the third energy shell. We start third period. Okay, so now let's go back, see that. Okay, so neon, second one closed. Next one, sodium. First one closed. Second one closed. Sorry. Okay, so we start third one. 1 electrons. Sodium. Okay, magnesium. 2 electrons in third one. Aluminum. 3. 1, 2, 3. Again, the first one closed, second one closed, the third one has 3. Okay, so silicon has 4. You see the green one, and that's phosphorus 5 in third energy shell. Sulfur 6. See 3 here and 3 there. We'll have to keep counting the number. Inside close. Okay, so now we have another very active non-metal, chlorine. So first one closed, second one closed, third one have 4 over here, 3 over there, 7. Okay, so then the last one is argon, 8. So now the 8 is the what? Maximum number for the outer shell. So right now the third one is outer shell, right? Outer shell cannot have 8. Even we have more room for the third one. See, there's more room. Because third one can hold up to 18. But the last one, the outer shell, cannot hold more than 8. So you already have 8. So now the nature can open number 4, the fourth energy shell. Okay, so if you check the periodic table, you'll see the third period finished. Then we start second one. I'm sorry. The fourth one, number 4. Okay, you'll see the first one closed with 2. Second energy shell closed with 8. Third one closed with 8. Even there are more room. Okay, so potassium. So we start the number 4, the energy shell. I have 1 electron. Okay, in number 4. Okay, the calcium has 2 electrons in number 4. Now see what happens. So since we have number 4, so number 4 is the outer shell. The very last one, the outer shell we call, has 1 and 2 electrons. Then what? Number 3 is not the outer shell anymore because you already have number 4. Electron already fill in number 4. So now number 3 reopen because we have more room. Okay, see, the next one we call scandium. So now the last electron come back to number 3. Because number 3 is not outer shell anymore. See, so this we call transition elements. It's a little more complicated. So in physical science class, we're not going to discuss more detail. So there's a reason why the outer shell cannot hold more than 8. There's a reason. Okay, then next one, do we have one more? Yeah, next one. You have okay, 2 in outer shell and another 2 to the third shell. So now the third one has 10. Is that okay? Yes, because number 3 is not outer shell anymore. Number, number 3. Okay, so let's finish that. Go back to our lecture. I hope everything makes sense to you. Okay. Well, so there's a shell and a subshell. Let's go back to this one again. Okay. When n equals 1, there's only one shell. When n equals 2, there's 2 subshell. When n equals 3, 3 subshell, and 4. Well, how we know this? Can we see inside of the atom? Can we see the energy shell or subshell? No, not even today. We cannot see that. We can only see the whole atom. That's the Rutherford model. And I'm sorry, we studied that in chapter 8. So we can see 1, 2, 3 different atoms, but we cannot see inside of atom. Then why we should believe it? So how do we know? And why should we believe? Well, because we studied physics. We studied what we call the spectrum of elements. Different elements give you different light with different color. Different color tell us different frequency, and different frequency tell us different energy, right? Remember, the energy equals a constant times frequency. So from physics, we know that. Okay, and now from mathematics, well, we are not going to study this. This is called quantum mechanics. So people, they solve a very complicated equation and calculated the energy shell inside of atoms. Use mathematics. Start 1930. Okay, then in chemistry, we studied different elements. They have a different property. Which one's active, which one's inactive, the periodic law. Okay, so from different angles, physics, mathematics, and chemistry, they all give us same conclusion. For example, when Mendeleev gave this periodic table, this periodic table, of course, he has a very simple one. He didn't know the quantum theory at all. No, from different angle, physics, mathematics, and chemistry, we all got the same conclusion. That must be right. For example, if we have some students in my class that take tests together, let me choose a few of my favorite students. And this one is Nathan from my Monday class. This one is Michael from my Tuesday 9:30 class. And Emily from 11 o'clock class. The one more student. This student name is Ben Dover. Ben Dover. I don't know which class from. Okay, so suppose we have 4 students take same test, my physical science. Well, if they all have the same answer, most likely they have the right answer, right? But if they have a different answer, well, something must be wrong. Well, maybe they didn't study. Maybe I gave a wrong problem. See, so that's the reason. Because physics, mathematics, chemistry tell us same thing. So that's why we believe this model, energy shell and energy subshell, and from this energy we understand much more about the atoms, the elements. So now we're going to study a little more detail about the periodic table, and we're going to answer the three special groups. The first one and the last two. Why they're so active, also inactive. Okay, so now the chemical behavior or chemical property of elements mostly depend on the outer shell electrons. Why? Because the inside closed. So only the last one, with the last energy shell, the electrons over there determine the chemical property. Okay, so because the inside closer to the nuclear bond there, not going to change. Okay, only the last shell you have one or few electrons. It's easy to change. You may lose one, you may catch one, then they determine the chemical property or chemical behavior. So now we're going to answer a few very important questions. You see the hydrogen and alkali metals. The first group we call alkalis and hydrogen. So see, they have something in common, right? They all have one electron in outer shell. So the first one closed, the second one has one. That's lithium. The sodium first two closed, third one has one. Potassium, the first three closed, number four has one. They all have one electron in outer shell. So that's why they're so active. They want to lose this one, then inside closed. A closed one is more stable. Okay, so in chemistry, it's all about either lose electron or catch electrons to close the outer shell, become more stable. So the reason why alkali metals so active because they have a one single electrons. Now see the second one. The second column, second group, they also active, but not as active as first one because they have two electrons. Okay, so then you see we only check the outer shell. 1, 2, 3, 4, 5, 6, 7. So now halogens, fluorine. Why fluorine and other halogens are so active? Because they have 7 electrons in outer shell. Just need one more to close. Okay, 7 in the third shell, only need one more to close. 7 in the fourth, need one more close, and so on. This iodine. So they are so active in chemical reaction because they try catch one more to close. Just need one more close. Give me another one. Okay, so that's why. So they are very active because one electrons in outer shell. That's alkali metal. And halogens, non-metal. They want to catch electron to close. They want to catch one. Well, these oxygen, sulfur, they're also pretty active, but not as active as halogens because they need two more to close. See, they need two more. Okay, so most active because one electrons in the outer shell, most active because need one to close the outer shell. So now the last one, inert group or noble gases. Can you tell why they're so inactive? Inactive, like they don't want to join in chemical reaction because they are closed. They have 8 in outer shell. Neon, argon, krypton, xenon. So they have a closed outer shell. They don't want more electrons. They don't want to lose any electrons. So very inactive. See, that's the reason. So I'll give you all the definition here. Hydrogen and alkali metals, they have one outer shell electrons. So they're very active. Halogen elements, they need one electron to close outer shell. They already have 7, need one more. So they are also very active. they try to catch electrons. Inert gases or noble gases, they all have closed energy shell, 80 electrons. Well, other than the helium, because the first energy shell can only hold 2. So anyway, they're all closed, so they have no tendency to lose one or catch one. So they're very, very inactive. Uh, and the metals in general, they want give electrons. Okay, non-metal in general, they want catch electrons. So that's differences. Okay, so we're gonna stop right here. So we're gonna have third one for chapter 10. Okay, thank you.